Hello everyone. We already know that we can make use of Conda, which acts as a package and environment manager in order to install new set of packages to your environment or create a new virtual environment altogether for any new project that you are starting to work upon. Conda as a package manager or as an environment manager not only lets you create a new environment, it also helps manage the set of environments that you must have created for multiple projects that you must have worked upon. So before we get into intricacies of how you create a virtual environment, what are the different environments and how you manage them, let's understand why we would require a virtual environment in the first place. What is the necessity of having it? Let's say that in the year 2018, the data science team has created a particular project called Project A, and this is an environment specific to Project A. So they have built an environment first, and then they started to work upon project called Project A, and finally they have prepared this particular script which actually does some data processing and generates a result. So whatever result that it generates is perceived by the stakeholders and is well accepted by the stakeholders. The review has been thoroughly done, and whatever result that this script produces is okay for almost all the stakeholders along with the business users. Okay. So this whole project has been built by considering this environment where we observe 2.7 Python version, 14.1.4 NumPy, 2.1.1 Matplotlib. So these are set of packages or libraries that are being used for project A. So later in the year 2022, a new team arrives. This new team wants to make changes to the existing project A based upon the new set of requirements that they must have received. So first they are planning to rerun this script and reproduce the result that the team has produced in 2018. So for that, they have created a new environment. They have completely ignored the previous environment, but they have instead created a new environment which has got a Python version of 3.11.2. And they also have installed these packages or libraries called NumPy and Matplotlib. They have installed the latest versions, both of which holds the latest version as of 2022. So whatever code base that this script is using, the code base pertinent to either of these two packages or libraries is completely inconsistent with the code base that this new team is using, because there are so many changes that must have occurred to many of the functions or methods specific to the classes within these two different packages from year 2018 to 2022. Let's say that this script uses a specific function called quantile. So quantile is a function specific to NumPy module, and this is going to produce a specific result as an output, or probably this is going to produce an output which is acceptable or expected output as per the script that we have written in 2018, right? And there are so many changes that occurred to this particular function called quantile in the year 2019, 2020, 2021, and 2022. Since the new team has installed the latest version of NumPy, the code that this quantile function used to have in 2018 is completely different in 2022. So obviously there is a high chance that this script might error out when you run in 2022. So there could be a lot of code inconsistencies in between the script that we have tried to run in 2018 by considering this environment versus the script that we have run in 2022 by considering a new environment altogether. I believe we have pretty much understood on why we would require a virtual environment in the first place. So the new team basically needs to consider this cloned environment as is and then probably run the script using this environment, or create a new environment which has got this Python version of 2.7, a NumPy version of 14.1.4 and Matplotlib version of 2.1.1. Then if they are running this script, it's going to run just fine, and whatever result that you might interpret will exactly be matching with what the team must have observed in 2018, because the code base that you are making use of with respect to these different packages is absolutely matching with what code base that you are now considering in the year 2022. So these inconsistencies has to be solved. Like this can be solved easily by considering the same environment, or by considering running the script or making changes to the script by taking into account the same environment as the team has used in 2018. So that's the whole point of having isolated environments. So these isolated environments can be specific from project to project, can vary from project to project. So depending on the nature of the problem that the team is trying to solve. So project B has got completely different set of libraries altogether. So they have this matplotlib in common, but the versions of matplotlib are completely different. Again, project C has got NumPy and SciPy both. The versions of NumPy is completely different from what we observe in project A. Again, SciPy is a new package that project C is using, which project B and project A is not using. So whatever environment that gets built is completely dependent on the nature of the problem that you are trying to solve and the project that the team is working upon, right? So every project should have its own isolated virtual environment. That's a good practice to do. Now, let's look at creating a new virtual environment for all the exercises that you are going to conduct from now. So in order to create a new virtual environment, so we are going to make use of the package and environment manager called Conda. So Conda create, provide the name of the environment. I can provide the name of environment as my_env. Just hitting on enter will help you create a new environment altogether. So once you hit enter, once you create the new environment, you can list the possible environments that you are currently having by providing this command called conda env list. Now you can observe that my environment is already created. There are other environments like base environment and venv, which I must have created for the different projects that have worked in the past. So base environment is an environment that Anaconda or Miniconda distribution would offer you, right? You can activate any one of these environments by providing conda activate the environment name. So if you observe on the left hand side, now it is pointing to my environment. So you are currently working on this new environment called my environment. So in order to deactivate this environment and navigate back to the root directory, I can simply provide conda deactivate. So this takes me back to the root environment or probably the root directory. Now, instead of creating a new environment, I would want to create a new virtual environment specific to a location. I would want to create a new project directory first and create a virtual environment within that project directory. So just like before, I am going to make use of conda create, provide a prefix because I would want to create the new virtual environment in a specific project directory now, right? So when I say I would want to create this in a project directory, let's create the project directory first. So make dir test_project is a new test project that I am planning to work upon. So I can navigate to this particular test project and I can observe what are the contents of this particular directory called test project now. So I do not observe any contents. I do not observe any files or subdirectories that are present within this project directory called test project because this is newly created directory by me, right? So I just created it. So we cannot expect it to have any files or subdirectories in it. Cool. Now let's look at creating a new virtual environment and now provide a prefix with test_env. So test_env will be the name of the virtual environment I'm planning to have. I'm also installing Python of version 3.11.2. So now you understand why I have provided this prefix, right? So I have provided that prefix basically to indicate that I need to create my virtual environment within a specific location. Probably to create the virtual environment in the location of my project directory that I have newly created. Okay. Now you can basically look at the files present in this particular directory called test project. So now we understand that the environment directory is created here, right? So this is what we have expected for. And now we can activate this particular virtual environment by providing conda activate test_env. So now if you are observing on the left hand side, so it's pointing to the newly created virtual environment that is test environment. I can also check for Python version because I have installed the Python version of 3.11.2 already. I can check the version of Python. Now it's matching with whatever I have provided while I try to install the virtual environment. Okay. Now let me also install few additional packages. So I did mention to you that we can make use of this package manager conda in order to install additional libraries or packages. So conda install pandas is going to help me install pandas library or pandas package. It also installs the necessary dependencies associated with pandas here. There could be some dependency packages with pandas, right? So all the dependency packages along with the pandas package itself gets installed now. It will take a while for it to install basically because there are too many dependencies that are to be solved. Once I have installed this package using conda install pandas. I can also list what all packages are present within my virtual environment along with their respective version numbers. Now I understand that these are the different packages that are available within my virtual environment. And I also can observe what are the different versions associated with every individual package here. So I can observe that pandas is now created or now installed with a version of 2.1.4. Python also is installed with a version of 3.11.2. Pip, which again is a package manager, is also installed with a version of 23.3.1. So pip gets installed with Python installation itself. That's what we have learned earlier, right? You can install any of the packages that are present in Python package index using this particular package manager called pip. It's not necessary that you can always install specific packages using pip package manager. You can also install them using Conda. You can try both. Cool. For whatever packages that we have now observed with their respective version numbers, there could be some of our fellow team members who might ask for them, right? They might ask for collaboration. They wanted to understand what are the different packages that I have installed in my environment and what are its version numbers associated. So then I can easily list down all of these packages. I probably would want to write all of them to a specific file called requirements.txt. Now I can observe if this file is written or not. So I can also find requirements.txt now. So I have two different files, one of which is requirements.txt. The other one is the subdirectory which is specific to the virtual environment that I have created. I can share this requirements.txt file with any of the fellow data scientists or developers for them to understand what are the different list of packages that I am using as part of my environment and what are their associated or corresponding version numbers. So they can simply go about installing all of them. They can simply install all of this, right? Like conda install -r requirements.txt. I'm not going to run this command basically because I already have the list of libraries that are listed in my environment. The team developer or the developer within our team, whoever wants to install all of these packages into his environment, then they can simply go about executing this command of conda install -r requirements.txt. I'm not going to do that. But however, I'm just trying to clone this environment or export this environment as such so that I can share that file with any of the other users. So they can ultimately import the environment and use it directly rather than sharing requirements.txt file. So conda env export -- prefix. So what is the environment that we have created? Test_env, right? So I am trying to save this as environment.yaml file. And that's it. I just hit enter so that whatever environment that I already have now gets exported to this YAML file. I can simply check what are the contents of this particular directory test project, right? Now the contents of this test project are test_env, which is the environment that I have, the directory pertinent to the environment, requirements.txt file that I have created, and the environment.yaml file that I have now created. So we can either share environment.yaml file or requirements.txt file to other members within the team so that they can actually clone your environment or probably create their own environment by considering requirements.txt. By installing all the libraries or packages that are listed within environments.txt, since it also has the respective version numbers associated with every individual package that's listed there, right? So these are the different steps that one can follow while creating an environment. So once all the process is done, you can simply deactivate the environment. So deactivating the environment now takes me back to the root directory, right? I'm just back to my root directory. And you can also list on the environments that you have now created. Now we observe that a new environment called test_env is created under a directory called test project. So this is what we have created just now, right? This is what we have created just now. We basically have understood the process of how you create a virtual environment, how we basically can install additional set of libraries or packages. And then once we install additional set of libraries or packages, we can actually write all of them and their respective version numbers to requirements.txt file for sharing it with the fellow team members. Again, we also have exported the environment into a YAML file, which again can be shared with the team so that they can clone the environment that we have created. Okay. So in the next session, we are going to learn more about the different IDEs that there are, and we'll learn a little more about Jupyter Notebook. How are we going to run Jupyter Notebook? How are we going to make use of Jupyter and try and understand how we can run Python code there. So before we get into all of that, right? So let's activate the test environment that we have just created by actually navigating to the test project folder, right? First, test underscore project. So now I am in the project folder. Now I can simply go about activating this virtual environment called test underscore env. I can also install Jupyter, which can be used in my next session. So you'll understand more on why I'm installing Jupyter here in the next session. Okay. So that's all in this particular session, and thanks for watching.